Hey, hello guys, welcome, Vandanam, Namaskaram. Today we are going to see applications of derivatives. Very important lesson and very big lesson. Okay, maybe if you sum all of the seminars that I'm going to take for this lesson, it might be like around 6 seminars. Okay, it might be around 6 to 7 seminars. It might be because this is such a big lesson and we have to check each and everything, right? So there are totally 5 important concepts that we will have to cover in this lesson. Namely, first is rate. Okay, first is rate. This is what in the first exercise of NCERT. Okay, very easy. PC thing this is. We will cover just like this. Okay, this is very easy. Then after that we are having approximation. Okay, so this is not for NCERT, this is only for JEE. Then after that we are also having tangent and normal to a curve. This is also not there for NCERT. Tangent and normal to the curve. Okay, these two are not there. Next is we are having increasing and decreasing. This is there for NCERT, increasing and decreasing. Okay, this is there. Then at last but not the least is our monotonicity. Okay, which is our maxima and minima. Okay, and this concept is very important. Monotonicity is very important. Actually, all these three are very important. This. Okay, sorry, this, and amongst them, if you are feeling one of these concepts are going to be tougher now, then this concept will be kind of moderate. Okay, because this is very lengthy topic, but if we understand, then this is going to be very easy. And these two are for JEE. Okay, and in this as well as this is what here for NCERT. Okay, and even exercises are based on these 3 concepts. And if you are checking in the old NCERT, then you might have these 2 and as well as these 3. Okay, so we shall begin. So first of all, I'm going to start with rate. Okay, derivative as a rate of change. Just rate of change. Okay, so first I shall say what does this mean, then we will come. Okay, for an example, this is a circle. Okay, you are having a circle. Now this circle is growing. Okay, you can take it as a black hole. Okay, you can take it as a black hole. If you want, you can take it as a black hole, and this is growing. Okay, and this black hole is very weak, so it is not growing in such a tremendous way. For an example, this radius, okay, is actually going to be 5 centimeters. Okay, just imagine. Okay, and per second. Okay, per second. I don't know in what rate black hole grows, or whether it grows or whether it doesn't grow, or what is the size of the black hole, that all I don't know. Okay, but just keep it as, okay, and this is growing. Okay, you know like how it is growing? It is growing in such a way where per second, okay, in per second, okay, for 1 second, it is able to grow 1 centimeter. Okay, 1 centimeter. That means in the first second, okay, the first second of growth, the radius of the circle would have become as 6 centimeters. Okay, then after in the next second again it will be growing, again it will be growing, right? In the next second it will be again growing. In the second, okay? In the second, it will be growing, and now it will be in the second. So now again 1 centimeter. So that means the total net radius of the circle is going to be 7 centimeters, isn't it? So how will you represent this? That it is growing per second, it is growing 1 centimeter. Okay, so that means radius is being increased 1 centimeter by 1 centimeter for a second. Okay, so per second this much amount of length of radius is being increased. Okay, so you will be representing this as 1 centimeter per second. Okay, which it means that for 1 second, okay, 1 centimeter of growth is there. That is what it means. For an example, if you take humans, we all grow, right? So for an example, I can take, how many centimeters do we grow per year? Approximately 15 or 20 centimeters, maybe. I don't know how much we grow. So that means that can be represented as 15 centimeters or 20. I will take. Okay, so 20 centimeters per second. Sorry, per year. Per year. Okay, and this SI unit in this lesson is very, very important. Okay, and for this SI unit, you should have known some basic concepts of physics in the first lesson of physics, even, which is units and dimensions, I think. Okay, there they are, units and dimensions only. So there, in a tabular column, in errorless there is tabular column. I don't know whether in NCERT there is tabular column or not. They would have given 7 basic units, isn't it? Okay, there is candela, then there is meter, then there is second, then there is kilogram, then there is mole. Okay, and still 2 more are there, I have forgotten, but 7 are there. Amongst them, here what you are going to use is only 2 only you are going to use. That is length and then time. Okay, so SI unit, when you are talking about the SI unit, length SI unit, we all know that is 1 meter. Okay, and time is actually 1 second. Okay, but in questions, not in every question they will be giving 1 meter. They would have given it as 1 centimeter. Then you can proceed with 1 centimeter itself. Okay, what is a unit? Okay, what is a unit? Unit is something that is we use to have a standardized measurement. So 1 second now, it is 60 milliseconds. Okay, so 1 meter in sense it is 100 centimeters. Okay, like that we are having micro units and as well as macro units. Amongst them, scientists have chosen this to be the SI unit, and here also this is to be the SI unit. Okay, so that we all can do a standardized sum. For an example, in social science of class 10th you would have studied, right? L, that is the length of the cloth. Okay, it was differing. 1 meter was different for each and every place. Okay, like that only. Even in the olden days, some people were using length unit as feet. Okay, they were using feet. Then another group of people were using centimeters as SI unit. Some other people were using meters as SI unit. Because of this, okay, there were lots of backlogs. Okay, so to take out all those backlogs and to improve in all these scientific ways, so what they have done is they have cancelled all these and they have taken meter as the SI unit. Okay, and the CGS unit also they have kept that is centimeter. Okay, and then the bigger unit is going to be the kilometer. Okay, and one important fact, that is for time, SI unit is also 1 second and CGS unit is also 1 second. Okay, this is the one and only unit. Okay, this is the one and only thing that has its SI unit and CGS unit as the same. Okay, and also one more thing. Mostly SI unit will be greater than CGS unit. CGS unit is the lower unit, SI unit is the greater unit. Okay, but not everywhere, mostly. Okay, but in case of current alone, it's not like that. In physics, we will be talking about it. Okay, since we have completely gone towards physics units, now we will come back here itself. So now we shall discuss about some other units. Okay, I hope you all have got some basic idea about what does it mean. Even in biology, population and the organism, population and organism, that lesson name. In that lesson, you will be having the particular where 2 pages will be there. Okay, and yeah, 2 pages will be there. You will be having 3 different formulas. One is going to be the differential formula, another is going to be the integral formula, then the logistic formula. Okay, and over there they would have given graph. Even that in that graph also they have used this only. So population in that alone they have used some derivations. Sorry, differentiability and differentiations. Okay, that is differential equations they have used, not derivations. So, okay, so now if a function y, okay, y f of x, okay, this is a function, okay, which is equal to y, and we all know that the driving force over here is x. Okay, the driving force is over here is x. Okay, if there is a small change in x, okay, then there will be a change in f of x also. Okay, but you might say, what about constant function? In constant function, no matter what the input that we give, the output will be the same number only, right? Well, yeah, what you're saying is correct only, but that's one of the most critical exception that we can give for this definition. And also, constant function is having a very amazing character in this lesson in maxima, in increasing and decreasing, I'll say to you. Okay, it is a really amazing thing. Lots of people get confused with that. Okay, even when I came to know for the first time, I was like, how is this possible? Okay, so we will check over there. Now we will come here. That is, see, what they are saying is, if there is a small change, okay, if there is a small change in x, then there will be a small change. Okay, then there will be a small change. Then there will be a small change. Okay, even in f of x. That means if you change this x, okay, then this y will be also affected. If you change this x, then there will be a change in y also. That is what the basic concept of integration is. Sorry, differentiation is. Okay, so that means we can write it as rate of change of y, okay, rate of change of y with respect to x. This is what I was talking about. If there is a change in x now, then there will be a change in f of x, which is y. So when you there will be a change in here when there is a change in here. Okay, and also note, okay, note, even here that circle I said, right, this circle I said, right, if the time is constant, then there will be no change. Okay, if here the time over here, okay, is constant. For an example, if the time doesn't move, you can take Doraemon. Okay, I see Doraemon a lot. There will be this time watch where if you click a button, then the time will be stopped. Okay, like that. If in case the time is stopped, then the circle will not grow. Circle is growing with respect to time. If there is no change in time, then there won't be any change in the circle also. Okay, in the radius of the circle also. And because of that, okay, here when you are comparing just the radius of the circle and the time, here the driving force is time. Okay, when there is comparison between radius and time, only the driving force is time. But when you compare the radius and then the area, okay, there the driving force is going to be your radius. Okay, not time. It depends. The driving force will be always in the denominator. Okay, driving force will be always in the denominator. Okay, and the thing that is being changed, for an example, when there is a change in radius, there will be also change in area. That thing that is being changed, right, that will be always in the numerator. That is why even for time, okay, for increase in radius per second, we were writing time in the denominator because the driving force is time, and the radius will be in the numerator because radius is not the driving force when there is change in radius. Okay, you have to understand this. So this is what it is, and there will be change. So that means here the driving force is x. Okay, here the driving force is x because whenever there is a change in x only, you will be getting a change in f of x. If there is no change in x, then there will not be any change in f of x. Okay, so we can say it as, so then what? Then in the denominator x will be there, and in the numerator f of x will be there. That's it. Okay, very simple. And f of x is equal to y. Okay. F of x is equal to y. So this sentence I can write it as change in y with respect to the change in x. Okay, so that means what? y2 minus y1 whole divided by x2 minus x1, which is equal to c. Change in x term, in that, what does it mean? That means first, okay, first there would have been one value. Okay, so for an example, you take it as 2 centimeters. Okay, then after once again it would have become as 3 centimeters. Okay, then now what is the change? Okay, now what is the change? From 2 to 3 it has become, right? So the change is going to be 1 centimeter. Isn't it? Okay, so then automatically, okay, when x was 2 centimeter, there would have been 1 y. Okay, there would have been 1 y. Okay, imagine the same circle and the circle is growing per second. Okay, so when and y is the area. Imagine that. Okay, imagine that y is the area. So now then what would have been the area? Area would have been 4 pi centimeter per second. Area, so that's not centimeter square. Okay, 4 pi centimeter square is what the value of area will be when x was 2 centimeters. Now this, okay, this will be y2, okay, and now it will be 9 pi centimeter square. Okay, by the way it is 9. Okay, 9 pi centimeter square. Now you can see that there is a change. Whenever there is a change in x, this is what x, okay, there will be automatically a change in y. So y, and this is what it means. Okay, this is what it means. And since mostly x2, okay, since mostly x2 will be greater than x1. Okay, this is what x2, this is what x1, okay, this is what y1, this is what y2. Okay, mostly, okay, x2 will be greater than x1. Because of that, okay, so because of that, they are using this formula. Okay, and also there won't be any problem. Okay, this is also equal to this one. Okay, these two are same only. What is the difference? There won't be any difference. Okay, if you take minus common here and if you're taking minus common here, then minus will be cancelled. Then you'll be getting the same thing only. Just take minus common. Okay, from here if you're taking minus common now, then it will be becoming as y2 minus y1 whole divided by x2 minus x1. Okay, see change. So nothing. So there is nothing wrong with that. You can take either it as y2 minus y1 or x2 minus x1, or sorry, yeah, you can take it as y2 minus y1 or y1 minus okay, why? See, if you can take y2 minus y1 or you can take y1 minus y2. Okay, but note, if you are taking here, okay, y2 minus y1, then in the denominator also there should be x2 minus x1. You cannot take them like interchanging. That's not fair. You cannot interchange it. Okay, so you cannot interchange it. And can you guys see this formula? Have you guys ever seen this formula anywhere? Can you all remember straight lines, the slope concept? That is what this is also. Okay, same formula. K is equal to m, that's it. Okay, but we are not going there, but this is why we will be saying that differentiation is equal to slope. Okay. Okay, so now you have this, which is further equal to delta y minus delta x. Okay, so delta means this change. Okay, from this to this it had converted. Okay, it had got converted. From this to this it had got converted. That is what this delta means. And whenever change is big, okay, whenever the change that you are having, okay, change itself is actually of two different types. Okay, so the first type of change is a big change and second is a small change. You just keep it like that. Okay, so which color shall I take? I should take yellow color. Okay, so change is actually of two different types. One is going to be a big change. Okay, then another one is going to be a small change. Okay, and when you are having a big change, then automatically you will have to use delta. So delta y by delta x. This is correct for delta. But when you are having a small change, there you are not supposed to use delta. To indicate that it is a small change, you will have to use d. Okay, dy by dx. Okay, this is what dy by dx means. Okay, well, over there I thought to explain everything, but since if I'm explaining over here, then the understanding will be still more better. And if I've explained over there, then now it will be kind of boring. So that is why we are talking everything now very clearly. Okay, but I have given basics over there also, that concepts. Okay, we will again cover those here. Okay, so delta y by delta x, then here dy by dx. That's it. Okay. And when and also you all know I said in the differentiability itself that dx must be small. Okay, then only it will be correct. Dx must be small, then only the value that you are expecting, the change in this value, this ratio will be correct. If you don't know why, please go and watch differentiability. Do not watch full video, just watch for first 10 to 15 minutes, then you will know why dx should be small. I've explained it very clearly. Okay, so dx should be very small. That means what? Okay, that means what? Dx should be tending towards 0. Okay, so your dx should be tending towards 0. Okay, or delta x, that's not a big thing. Okay, or delta x will not come. Okay, delta x will not come. Delta x means, delta means big. Okay, big change in x cannot be tending towards 0, right? Small change value will be tending towards 0. That we all know. Okay, so dx should be tending towards 0. This I said very clearly in differentiability. You can go and watch there. Okay, so whenever it is tending towards 0, then what do we use? The word tend means limit. Okay, the word tend means limit. Okay, class 11th we all have studied it. So limit we will have to use. Okay, so limit where dx tends towards 0. Okay, so dy by dx is what the formula that you are going to use when dx is very small, and dx should be very small to get accurate values. If you are getting if you are taking dx big now, then the error percentage will be also becoming big. I have given you the relation between dx and error percentage. I have given you how it had come. Okay, everything in the differentiability itself you can go and check. Okay, so now I will take, that's it. Okay, so this is what the basics that we have to discuss. Here after everything is question only. Okay, everything is full of questions. One second. Okay, so you all can see what an amazing thing. Oh no, you are not supposed to show off. So what an amazing thing that I've done. You all can see that I've cropped the image and I've placed here, and I was like, oh, this board is having this option also. I didn't know for these many days. What sort of person am I? Because for these many days I was writing the question, right? But those questions have taken from different places, so that there's no way that I can crop those. But whatever the questions that I'm trying to take from NCERT, I can take here after very easily. Well, so here you are having a question where this is actually same sort of model, not the same question, model like that. Okay, we are also having in JEE. Okay, one time they have asked that question also. Okay, see, a ladder is there. Okay, so it's leaning on the wall. This is what the wall. Okay, this is what the wall is. And we all have studied in the applications of trigonometry of class 10th itself. Any object that is being connected to the ground will be perpendicular. Okay, this wall and then this ground will be perpendicular to each other. That we have studied in 10th standard itself, because any object that is being placed on this earth, okay, on this ground will be perpendicular. Okay, for an example, if I'm standing on the ground and then I'm perpendicular to the ground. Okay, now I'm having another thing. Okay, We are having a ladder. You are having a ladder. Okay. I have a very great ladder. Okay, this is a ladder. Okay, so this length of this ladder is actually 5 meter. Okay, 5 meters long. Okay, this ladder is leaning against a wall. Okay, there is a wall, and this is what that wall. Okay, this ladder is leaning against the wall. The bottom of the ladder is pulled away from the ground, away from the the bottom of the ladder is pulled along the ground away from the wall at the rate of 2 centimeters per second. That means what? This ladder, okay, is being pulled like this. Okay, then it will be coming down, and here it will be increasing. Okay, away from the wall, it is being pulled along the ground, and since it can be either this way or this way, and they have given us a very good information that is away from the wall. So that means it's pulled like this. Okay, and now here it is decreasing at the rate of 2 centimeters per second. That means it is being pulled right. That rate they have given. What does it mean? That means per second, okay, per second, it is going away from this wall 2 centimeters. Okay, 2 centimeters is the distance that it is traveling away from the wall per second. Okay, how fast is its height on the wall decreasing when the foot of the ladder is 4 meters away from the wall? When the foot of the ladder is 4 meters away from the wall, that means, okay, so imagine this to be the x distance. Okay, x meter. Okay, x meter. Okay, this wall, this ladder is being pulled 2 centimeters per second. That means per second it is going 2 centimeters fastly this way. Okay, then what will be this rate? Okay, here it will be decreasing, right? Here it will be decreasing for with some amount of distance. Okay, with some amount of rate it will be decreasing. Okay, so that rate, okay, what is that rate? What is that rate? Is what they are asking. When this wall is exactly 4 meters, exactly 4 meters away from the wall. Okay, away from the wall. So this is the rate that they are actually asking us. Okay, so now then I will draw a very different diagram for this condition. This is what the ladder was. Okay, this was the condition. Now the condition is like this. Okay, so this is 5 meters, this is 4 meters. Okay, and then this is going to be some sort of x meters. And we all know that this is not going to be less than 1 meters. That is actually some laws of triangles. Okay. Now you can use trigonometry. Okay, or sorry, you can use Pythagoras theorem, where x square, okay, where x square plus 4 square is equal to 5 square, which is equal to 25, minus 16 is equal to x square. So x is equal to 3. Okay, because x square is equal to 9 and x is equal to 3. Okay, so you have got 3 as your x. This is your condition. For this condition, your x is going to be 3. So that means when this ladder is 4 meters away from, okay, away from the wall, then this x distance is going to be 3. Okay, it's going to be 3 meters. Okay, it's going to be 3 meters. Now what they're asking us to find is this rate. Okay, this rate. Okay, so you come back to this condition. Since to find x only we did all of this. Okay, so now we will come back to this condition itself. So we all know that x square, okay, you just keep it as y, you keep it as y, you keep it as x. Okay, so x square plus y square is equal to 25, isn't it? Now you will have to differentiate it. So it will be 2x, and a differentiation with respect to dt. With respect to dt. Okay, so 2x into dx by dt plus into dy by dt is equal to 0 because 25 is a constant, so it is going to be equal to 0. Oh, something is happening. Oh god, I have taken it out now. Oh god. Okay, so we will just remember this. We will just remember this. Some technical issues are happening. So now you have this, right? That is 2x into dy by dt plus 2y into dy by dt is equal to 0. Now, what is x? Okay, x is going to be 3 meters now we got. Yeah. So 3 into dy by dt is the thing that they are asking us. Plus 2 into what is y? Okay, y should be 4. And they have given us dy by dt. What is dy by dt? It is actually 2 is equal to 0. And by the way, dy by dt, you can see that here it is decreasing. Whenever there is a decreasing rate, what you have to do is you have to put here minus. You will have to put here minus. This thing I've said in chemical kinetics. Okay, why are we putting here minus? Okay, so we will come here. It is going to be 6. Okay, or I can take, I will just cancel this 2. I will cancel this 2. Okay, then here I will be having dy by dt. Okay, so dy by dt is equal to minus 8. Here also minus is there, 3 is there, minus can be cancelled out. Okay, so then now you'll be having dy by dt is equal to 8 by 3 centimeter per second. Okay, 8 by 3 centimeter per second. Very easy sum. Okay, but this is something that many of us can be confused. We might get confused, so that is why I have given this. Okay. Still one more sum we will do. Great. So some sort of technical issues. Why am I having all these? Because I don't know how to use this board. So this is the sum that we are going to do. Who said that sum should be always on the top? Are this is killing me. This is so killing me. One second. Here it is. This is our question. By the way, marginal cost definition is actually how much amount of rupees is required to produce one more product from this product to that product. So there is a difference. Or if you don't understand that that definition now, then you can keep that marginal cost. Okay, they are asking us to find the marginal cost only. Okay, see, they are asking us to find the marginal cost when 17 units are produced. You can keep that marginal cost. Okay, marginal cost is equal to differential cost. Okay, what does it mean? That means you will have to first differentiate this equation, then you will be getting a quadratic equation. When you differentiate a cubic equation, you will be getting a quadratic equation. In that quadratic equation, you will have to substitute x is equal to 17 because they have given you 17. Okay, then you will be getting an answer. Okay, then you will be getting an answer. That is going to be an answer. Okay, first we will read the question. Okay, first we will read the question, then we will come here. The total cost is actually C of x is your cost. Okay, rupees associated with the production of x units. So to produce these many units, okay, for an example, to produce 100 units, okay, 100 units, then C of 100 is going to be your cost. Okay, C of 100 is what your rupees. Okay, this is what your cost is. Okay, then to produce 17 units, okay, of general cost, not marginal cost, general cost is going to be C of 17. Okay, to produce 17 units, okay, to produce 17 units, your cost is going to be C of 17. Okay, C of 17. Now, marginal cost in sense, you will have to differentiate it. With respect to what? With respect to x, you will have to differentiate. Okay, because here the driving force, you can see that the driving force is going to be x. Okay, if the number of units differ, then the total C of x will be also differing. So that is why here the driving force is x. So you will have to differentiate it with respect to x. Okay. So C of x is equal. Sorry, C of x. Here it is equal to 0.007 x cube. Here it is plus or minus r. Minus, okay, minus 0.003 x square plus 15x plus 4000. Okay, so this is what your question. So first you will have to differentiate it. So that means c dash x, okay, c dash x is equal to 0.007 into 3x square minus 0.003 into 2 into x plus 15 into 1 plus 0. Okay, so this is what your differential equation is going to be. Now, I will simplify this further. Okay, so 0.021 x square, okay, minus 0.006 x plus 15. Okay, now we will substitute the value at x is equal to 17 because that is what they have given. Okay, so when you substitute the value, then you will be getting your answer, your finalized answer. Okay, so 0.021 x square. What is x square? That is 17 square. Minus 0.06 into 17 plus 15. Okay. 17 square is 249, huh? Okay, so when you just simplify this, I'll just directly write the answer as I have the answer. Okay, that is 20.967 cost. Okay, so your marginal cost is going to be 20.967, but you cannot use calculator. Okay, you are not allowed to use calculator. Okay, so this is going to be the way that how you are going to do your sum. Okay, so this is how the rate is. We will do some JEE questions. we have lots of questions from JEE. Okay, so not lots of questions, just 3 questions we have. We will do those. Okay, so this is a question that was asked in April 2019 JEE mains. The question is that there is a water tank. Okay. A cone shaped water tank. A water tank has the shape of an inverted right circular cone. So which means there is a water tank. Okay, right. I will check whether it's there that shape. I have. Oh, okay. Okay, so this is your water tank, okay, which is actually inverted. Okay, which is actually inverted. Okay, right circular cone. What does it mean? It means, okay, this is a circular cone, okay, and hereby you will be having, okay, a perpendicular. That is what right circular cone mean. Okay, so whose semi-vertical angle is tan inverse of 1 by 2. What is semi-vertical angle? This is going to be your semi-vertical angle, which is theta. Okay, your semi-vertical angle is going to be theta. Now, water is poured into it at a constant rate. Okay, this is what your semi-vertical angle. So this theta is what equal to tan inverse of 1 by 2. Okay, so which means what? Which means tan theta is equal to 1 by 2. So tan theta, in sense, it's going to be opposite by adjacent, right? So that means I will keep it as radius r. Okay, I can keep it as height h. Okay, so that means r by h is equal to 1 by 2. So I can just say it as, okay, so r by h is equal to 1 by 2. So r is equal to wait, we will come to this conclusion later. Okay, so this one you have to know. Now, next is, with water is poured into it at a constant rate of 5 meter cube per second. Okay, see, after completion of this questions, I will go to units, because SI units are very important. Okay, so here what I am saying is, water is poured into it at 5 meter cube per minute. That means, sorry, not second, per minute. So which means water is being poured, and per minute, okay, per minute, it occupies 5 unit volume. What is unit volume? This is what unit volume will be saying it as. Meter cube is what unit volume. Okay. Now, then the rate at which the level of water is rising. Okay, that means there will be this water level will be rising, right? As water is being poured into this tank. Okay, that water will be rising. It will be going up, right? That rate of rise. Okay, that rate of rising is what they are asking in the question. Okay, and in that particular instance, okay, where your h is equal to 10 meters. Okay, so where your h is equal to 10 meters, and okay, so they have given the volume. What is volume? Okay, volume is equal to 1 by 3 pi r square h. Okay, this is what your formula, and they did not give any information about r. See, when you are having, okay, a question like this, and information about h is given, information about v is also given, okay, some rate like that they have given, okay, but they did not give anything about h. So r, in that time what you have to do is, you will have to substitute r, okay, by some other value which you already know. Okay, see, here you can use this, okay, and you can say very easily that r is equal to h by 2. Now you can put it in that equation. So when you put in that equation, then B is equal to 1 by 3 pi r square is what? R square is equal to h by 2 into h, which is equal to 1 by 3 pi into h square, okay, by 4 into h, which is equal to 1 by 12 pi h cube is V. See, this is what the equation that you have got. Now you will have to differentiate this equation. Okay, so dV by dt with respect to time only. Okay, with respect to time only you have to differentiate. Not only here, in most of the cases you will have to differentiate it with respect to time. Okay, because the driving forces over here is time. Okay, is 1 by 12 into pi into what is h? These all are constant. Now h cube. Okay, so what is h cube into 3 h square into dh by dt. Okay, dh by dt. Now dv by dt is going to be 4. Okay, so 1 by 4 pi h square into dh by dt. Okay, now what is dv by dt? Here you are having 5. Okay, so dv by dt they have given that is 5. Okay, 5 is equal to 1 by 4 into pi into h. Okay, h is at 10 meter. So into 10 square into dh by dt. What is dh by dt? And that is what they are asking. Dh by dt is what they are asking. Okay, so dh by dt. Now it is going to be 20 by 100. 5. So 1 by 5 pi is equal to dh by dt. Okay, so this is your answer. This is your answer, and this question was answered, and this is very easy question. So I said there are 3 questions, right? Already 1% we have done. That means that NCERT model, that same model only, okay, with some difference, some little bit higher order. That's what they have given. This is one sum. Okay, this is enough. As I said, this is very easy lemon squeezy. Now we will go to units. Okay, very important thing is units. Now, first, okay, at most what all you are going to use is length you are going to use. Okay, then you are going to use volume. Then you are going to use area. Okay, then you are going to use time. Okay, volume. Other than this, we are not going to use any other thing. Other than this, we are not going to use any other thing. Okay, so now length SI unit is going to be okay. So what is SI unit of length? SI unit is meter. Okay, then CGS unit is going to be centimeter, and this is what highly used. Okay, CGS unit is what highly used, which is centimeter. Okay, in this sum I'm talking about. Okay, but in reality, kilometer is the thing that we are using in India. Miles is what they are using in America and in Europe. Okay, next is volume. That is SI unit of volume is going to be meter cube. Okay, meter cube, and then CGS unit is going to be centimeter cube. Okay, then area. Okay, so area of circle, that one's SI unit is going to be meter square. Okay, then the CGS unit is going to be centimeter square. Okay, then the time, okay, for this both is going to be just second. Okay, second. Now combinations of units, that is increase in length. Okay, increase in length, increase in length or decrease. See, whenever there is increase or decrease in length, then in that time your SI unit is going to be meter per second. Okay, well, it depends on the question. In the question, if it is like meter per minute, it can be also meter per minute. Okay, or else it can be also centimeter per minute, or also centimeter per second. So these are your possible, okay, these are your possible units. Okay, hereby you can have it as meter square per second, okay, or centimeter square by second, okay, or centimeter square by minute, okay, or okay, so I have written this again as centimeter. Okay, so or meter square by second I have written, centimeter square by second also I have written, meter square by minute, meter square by minute it can be. Okay, then hereby in volume, okay, actually this is an area, this is an area, and then this is in volume. Volume, you will be having meter cube by second, centimeter cube by second, then centimeter cube by minute, then meter cube per minute. Okay, so these are your possible SI units. Okay, now at last we are going to discuss some formulas. Okay, so hereby you can see some formulas, and shockingly in camera it is more clear than my eyes. Okay, I can see clearly. Okay, so first of all, we need not to remember by heart every formula that we have read in class 10th. Okay, some important formulas alone I have taken. That is, okay, this is hemisphere. Okay, this is hemisphere. Okay, then sphere, this is right circular cone, this is what right circular cone, and this is what that semi-angle is. Okay, then right circular cylinder, this here you can see it is perpendicular and here will be perpendicular. Okay, then here it is a cube, every corner is perpendicular, as we all know, right? Okay, and over here also every corner is perpendicular. Okay, so for cuboid curved surface area, well, there is no curve, okay, but curved surface area, in sense, it's just going to be, this is what H, right? Okay, H. So curved surface area means excluding this area. Okay, excluding this area, you will be having here by one area, right? Okay, here by one area, right? 1 second, I will just check. Do I have something to show you all? Nope, I don't have that. So imagine this is your cuboid. Okay, so over here, curved surface area means this area, this area, this area, and then this area. Okay, this area will not come and this area also will not come. That is what your curved surface area is. Okay, so Then what about total surface area? Total surface area, no? Then the entire area. Then what about the volume? Volume means the entire volume that is occupied, the entire space that is occupied by a cube. Okay. Well, the derivation of all these formulas are very simple. Okay. You will have to understand, that's it. What do you have to understand from your curved surface area? Na? Okay, see here, it is more clear in that, more than, it is more than that, it is more clearer, it is more clear than that image. Okay, so let it keep this as H. Okay, then which is B, this is B. Okay, so this is your B. Now which is your L? This is your L. This is your L. Okay, so you have to exclude this one and then this one. So first you will take this area. Okay, you will first take this area. So which is going to be H into L. Okay, which is going to be H into L. H into L. Plus, now you are supposed to take this top area. So which is going to be, okay, this is going to be B, this is going to be L. So it is B into L. Plus, okay, then you will have to take this area. Okay, so which is going to be L into H again. Okay, L into H. Then you will have to take this area. Okay, so, or did I say something wrongly? So hereby it is going to be L into B. Okay, L into B. So from this you can add it. So HL will be twice plus 2BL. Okay, so 2BL, so 2L, that is H plus B. This is your formula. HBL. So that means curved surface area, and then you are not excluding this one. Okay, you are not excluding this area. Sorry, you are not excluding this area and then this area. But instead of that, you are excluding. Okay, you are excluding this area and then this area. So which means, where is that? You have this, you have this, you have this, and you have this, but you don't have this area. And as well as you don't have this area also. So, which means, okay, so which means here you need not to do that much of change. But I will try it again. Okay, so that means you have this. Sorry, you don't have this. You don't have this. This and this you don't have. Okay, so first we will take this area. Okay, that is going to be L into B. Okay, plus this area. This is also going to be L into B. Okay, plus this area. It is going to be H into L. Plus, wait, now you cannot take H common, na? Arey Rama. Then this formula is wrong, huh? LBH. LBH. No, then how will you take common? What will you take common? You cannot take that as common. Then here it will be B. Then here you are taking B as common. So which means, give me some time. I have to analyze. Okay, so here you have curved surface area. Curved surface area in sense, it's not, okay, you should not include this one and then you should not include this one. Okay, but you have to include this, 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 then this. Okay, you are supposed to include all of this, the cornice. So top and bottom line you are not supposed to include. Don't include this and don't include this. Okay, include this, 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 this. All the small sides you are supposed to include, and this big side and then this big side you are not supposed to include. That's what it means. Okay, so now we will do. So first I will take this area. Okay, which is going to be H into L. Okay, plus again I'm going to take this area which is again going to be H into L. Now I'm going to take this area which is going to be h into, this is going to be h into b, sorry, this is going to be h into b, h into b, again h into b, plus, okay, this area I'm going to take, what is this? This is h into l, plus h into l, that is going to be 2hb plus 2hl. Now 2h I'll take it as common, plus b plus l. So yeah, I got it. So okay, now total surface area, now then you have to take entire surface area. So which means now you will have to also include this side and then this side. So just add it. Okay, just add it. So here it will be this. So which is going to be L into b. Okay, L into b plus L into b. So now you can take only 2 as common. So hb plus hl, okay, plus lb plus just lb. This is your total surface area, because you will have to add this, also this and this. Okay, then your entire volume is going to be lbh. That's it. Okay. Cube also same thing only. Right circular cone, it is a very interesting topic. Just the combination of many circles. You are just overlapping circles, and okay, a circle, and on that another circle, on that another circle. Then you will be getting a right circular cone. Okay, but whereas a cube is not like that. Cube is like orange. Okay, sorry, a sphere. I'm not talking about cube. Okay, a sphere. Sphere is like an orange. Okay, so yeah, that's it. You have to remember. Okay, see this formula we used in this video. Then we used. Okay, we may not have used all the formulas, but they might. We might have a requirement of many formulas. Well, this formula we will not use. Okay, this formula will not use. Hemisphere we will not use. We might use pure. We can use right. We have used this one. Okay, this concept. Then also cube have we used? No, but triangular concepts we used. But there are sums. Okay, in NCERT you have sums. So we will have to remember these 5 alone. Okay, mainly this they will not ask that much, but these 5 you will have to remember. Okay, so that's it for today's video. We will be meeting in another amazing video. Till then, bye bye.